Welcome everybody. So this is a presentation by iKVA talking about the revolution that's happening in enterprise discovery at the moment using vector mapping techniques. Just a few bits of housekeeping just before we start. So this is going to be around a 30-minute presentation followed by questions and answers. Everybody is on mute. We will be taking questions at the end of this, so if people want to ask questions, if you can actually wait until the end, but if you do want to ask questions, then please use the chat session to ask those questions, and we will answer them at the end. This session is being recorded, so if you do want to distribute this recording of this session to any of your colleagues, feel free to do so. We'll be distributing the link to that session after this session is completed. So just a little bit before we start, just a very short introduction to iKVA. We're an early stage AI knowledge management company. We're actually born out of research that started off in Cambridge University and also the Alan Turing Institute, based on looking at information in a very different way using vector mapping technology. Now, if you want to know more about vector mapping technology and exactly what that is and how it works, we actually did a webinar on this last week, which went into by one of our founders and CTO, Professor Richard Mortier, which goes into the details of that. So if you're interested in that, please check out that webinar. When we send out the link to this webinar, we'll send out the link to that previous webinar as well. We're based in Cambridge itself, and as I said at the very start, we're an early stage AI company. We use this vector mapping technology to look at information in a very different way to what I would call most traditional enterprise search techniques, which enables us to really give organizations access to information in a way that's just simply not possible previously, which helps organizations cut the costs of information discovery, reduce their risks, and be able to deliver the right information to the right people at the right time. So as I said at the very start, I'm Jon Horden. I'm the CEO of iKVA. With me, I have Ian Firth. He is our Chief Product Officer. So I think without further ado, I will stop the introductory babble and hand over to Ian, and Ian can take us through a revolution in discovery.
Thanks, John. I think just to repeat what John just said, this is part 2 of a webinar series. The link is actually here in the slides, but we will send it out as part of the pack we get afterwards as well. It's really worth going back and taking a look at that if you're interested in the technology that supports the solutions we're going to talk about today. I am not going to talk about, certainly not directly, about the technology in this webinar. So please go back and take a look if you want to get that deeper insight or get a better understanding once you've seen what we've presented today. I think the technology itself is very powerful, and hopefully, as you see the applications of it through this webinar, you'll get to understand that yourself too. So let's start by saying what I hear from customers, and it is backed up by analyst data, is that the rate at which data is growing is accelerating, and accelerating fast. The thing here is that the data that is traditionally made up and easy to access is not where the growth is occurring. The growth is all in that unstructured data, and this is the data that locks away an enormous amount of value. This information tends to represent learnings that are used from employees' heads, documentation that was intended for humans. Sort of things like specifications, project documents, reference documentation, knowledge base articles, chat sessions, and things like Teams and Slack. This data is rarely codified into databases and metadata. It's stored in repositories like SharePoint, Google Drives, Dropbox, CRM, support desk tools, bug trackers. In other words, really the wide and varied variety of tools that we use every day. We kind of tend to store things when we're ready to, usually with great relief that we've finished them. And at this point, we're generally not thinking about things we should do to make things easier to locate. We just finish a document, we put a link in an email, shut the laptop lid, go for a cup of tea, celebrate the fact that we finished what we're doing. So simple things like making sure the title even of a document is suitable for making it easy to locate are not done, let alone complex things that might support taxonomy generation. Companies can't put processes in place fast enough to build taxonomies around the data and manage keeping the data within these boundaries. The information is things you tend to lose when employees leave, or is locked away as part of a data set you acquired, maybe as part of a company or product acquisition. It tends to be in people's heads, and that doesn't scale, so growing the company or the services you offer can become very hard. Just to put some numbers on that, and I got these facts and figures together from various sources and customers fairly recently. I think they sort of make fairly scary reading. The cost of not sharing knowledge is estimated to be nearly $32 billion per year, according to the IDC. That's all cost that's made up from people reinventing IP, relearning things from scratch, generally not being efficient through a lack of understanding and making mistakes because they can't access their data. Now, if you then think that nearly 50% of employees struggle to find the information they need to do their job, you can sort of begin to imagine where that $32 billion comes from. And then 80% of that data is unstructured, and that's growing at 65% a year. If this is hard data to find and 50% of your employees can't find it, then that all really begins to add up. On top of that, it's estimated by 2025 that the world's data store will go from 33 zettabytes to 163 zettabytes, 80% of that unstructured. So it's really time to work out how to use this in a way that doesn't need complex cleansing and processing to utilize, because it's just not going to scale. I mean, that move from 33 to 163 zettabytes in just 3 years is huge. And just in case you can't imagine a number that big, because I know I can't, 163 zettabytes is equivalent to about 23 terabytes for every man, woman, child on the planet today. So it's an absolute huge amount of data. And something a little bit more specific to the engineering sector, where we do a lot of our work, is that 96% of data from infrastructure projects isn't used, and 90% of engineering and construction industry data is unstructured. There's probably a lot of correlation here between the fact that this data is unstructured and the fact that it's not being used. There is a huge opportunity here and in other markets to use this data to generate efficiency, effectiveness, and increased value and reduced risk. So let's talk a little bit about the revolution that we need to get past this vast amount of unused, unstructured data, as there really is very little point having information that's just using up storage and not adding any value. As I said before, the hard bit of all this data is that this is data that isn't being transmitted in databases or keywords or ontologies, but instead real-world information about the world around you. And obtaining the value from that is not something that previously has really been considered without employing consultants, building big data projects, training staff, basically making a huge investment and repeating this for each disparate data source or use case that you're trying to solve. Now, people are beginning to wake up to the value of this data now, but there's already lots of it. You've seen the rate at which it's growing, and that widening gap between the knowledge you have and the use it's getting is something that really needs to be addressed, because that gap is where your IP is hiding, supporting not just incremental change, but innovative change. And I hope today to show you how you can start on the path of using some of this data that is distributed all around you without that huge investment and make it available to everyone where it's needed and in immersive ways. Spending a large amount of time and money defining and executing on a complex path to labeling all the data isn't going to work. It's growing far too fast. And by the time you have a plan, the world's going to have moved on. So you need to find a way to use the data in its rawest form and start now or risk being left behind. Things like data lakes are fighting a losing battle because centralizing all the data you need and locating the data from it is just too hard, as more and more applications are created, and all of those applications are creating more and more valuable data every day. That rate at which is growing is just vast. We need to move to deployments that can support acquisition of data fast and deliver advanced outcomes with immediate returns on investment. So without further ado, let's have a bit of a look at how we're using the latest vector search technology to deliver value and solve these issues in ways that provide great flexibility and in a frictionless way. There is an exciting journey for data usage. Vector search technology unlocks the revolution away from enterprise search and into new, engaging world, where rather than the company data being used by specialist teams and part of specialist engagements and projects, this data becomes part of the daily experience for everyone, getting work done effectively and efficiently with increased quality outcomes throughout the organization. I'm going to start with the foundations, which I'll call Discover. This is the ability to gather and utilize all of your data and expose it to users in some simple and engaging ways. Then once those foundations are in place, you can unlock more value from the data, up-leveling its use, and make this data more actionable to support increased decision-making, generating insight from that information. And in future, you'll be able to use this data to even more effective ways, using things that move data from micro to the macro level, providing higher level impressions from the information to grow deep strategic understanding from it and drive longer term choices from the bigger picture, and exposing what we like to call horizons. Today, the focus is on discovery and that part of the journey. Having launched our Discovery 2 platform recently, I'm going to try and bring that to life with some demonstrations and use cases that show you how you can deploy these techniques to get the most from your data and quickly innovate with it, engaging and integrate it into workflows where the value can really power your company. So before I just dive into the demonstration, let me just explain a little bit about what I think you're going to see. The core things we're going to demonstrate here are about accessing all the data, which means using data that is from internal sources, and there are many of these. Each tool you use comes with its own data storage. You can't force all this into a single place, or you get into the game of keeping multiple versions of information and the challenges of management of this, and that's huge. People are most productive using the tools they want to use. So if you want to be efficient, you can't force everyone to use data in one place. Being able to add external information sources adds great value and support for this internal information. Linking activities maybe to current affairs or industry papers or blog articles, for example, can add great insight to help you know how your information relates to the world around it. And these sources mean that the data is in numerous sources and formats. It's in textual things like Word, PowerPoint, PDF, HTML, messages in those chat sessions we talked about earlier, and even audio from information like meeting recordings or training videos. Then, sort of once the data is gathered and available, you need to be able to locate that information from those sources and find that information that is valuable and relevant to the tasks you're trying to undertake. We need to do this in a reactive and proactive way, enabling you to discover things that you knew were there but could not find, but also uncovering things you did not even know existed. Traditionally, people only search for things they know exist, but the wealth of data available means that they are missing crucial information by not looking in the right places, or often not looking at all. This information could be in different teams' data stores, or in a tool that not everyone has access to, or even is aware of. So these silos of information are often accidental, and the value of sharing data is not always understood. And maybe people don't even realize they're creating a silo by starting to use new tools. Okay, so let's jump in to where the magic happens. Okay, so I'm going to start with this tool, which is really a visual way of explaining what our platform can do. There's a whole range of knowledge sources on the left here under this heading knowledge packs that cover things like academic papers, news sources, patents, knowledge bases, internal repositories and chat sessions. There's a wide range of disparate information here from a variety of sources, all with different document formats, sizes, structure, to cover things like chat sessions or YouTube videos, academic papers. Some of these sources are large too. So the archive source here, that's a data source that comes from Cornell University, is in excess of 4 million documents, and each of those documents is multiple pages long. Things like Wikipedia are 7-8 million documents in size. And we can use these document sources in combination or individually to dynamically form the data set that we want to search through and make information retrieval requests from. So I like to think of this as being your virtual single point of truth. You can choose what data set you would like to query from, and then use that as a data source to retrieve relevant information as if it was one data source, which means the results you get from performing a query are ranked across all of that data, considering it as one core set of data. Now, when we do the querying, we are not matching on keywords, as you will see. What we are doing is looking at understanding the query and what it means, and matching the understanding to the documents. So let me kind of show you what that means. If I start here in this free text, I'm going to do a search for global warming. Okay, so what's that done? That hasn't searched for the words global warming in all the documents and found documents that match that term. And in fact, I think if you have a quick scanned down these documents, it's found they don't actually contain the word global warming. What they contain is information that has the same concepts as global warming. So things that talk about climate change, weather patterns, extreme weather events, all those things that are associated and have the same meaning as global warming have been found. So it has done that by understanding global warming and then looking in millions of documents to find things that match and returning results incredibly quickly. So if I change my virtual set of data to include BBC News, you can see that immediately I also get articles from BBC News that are all ranked as part of the same result set in priority order and treated those as one complete term. I can even do something like include Wikipedia in Arabic. So let's take these ones out. What you're now seeing is all the articles in Wikipedia in Arabic that are relevant to this, because understanding is not a language construct, it's a meaning construct. So those articles in Arabic Wikipedia have the same meaning as the ones in English. So you can actually cross language boundaries here too. Now, you might ask, how relevant are these articles to this term? Well, there isn't much context you can gain from global warming. There is some context, and you can see it's actually done a pretty good job of understanding global warming. But the more text you put and information you put into the query, the bigger the understanding from that context can be. So we could just type lots more words into here and get a bigger set of data. But usually bigger data comes from other documents. So we can query from things like URLs. If I go to this web page here, which I happen to have open, which is also for the interest of being the same about global warming. If I come to here and use that URL in here, what that has now done is it has gone to that website. It has extracted all of the words from that website. It used our technology to get the understanding from that page and match the understanding to the data source we've got. So you can see you've got a result set. Again, they are different results from last time. Although the essence of the page is still about climate change, and global warming, the amount of context is different. So the results are now skewed towards the meaning and direction of that website we've come from. So you're now getting things that are relevant to the website you were interested in. And you can go one step further. If we look at something like this, which is an academic paper that I've got here about oil and gas extraction. This is a I think 25-page academic paper with thousands and thousands of words in it. Our system can deal with that document just as easily. So if I go to the document here, and let me actually find the document and drag and drop it in. Okay, so it's done exactly the same thing. It has taken that 25-page document, extracted all the information and knowledge and gained an understanding from that document and returned results that are relevant to that. And again, you can see these are all about oil and energy and gas and very relevant. And again, you can increase your set of things that you are querying across to get results in order. So you can see we've added a Wikipedia result in there as a very relevant result high up the result sets. So kind of if you imagine maybe being a product engineer at this point, you could drop in your latest engineering definition document into a tool like this, and you could locate all the relevant information instantly across all of the data sources you've got. So those data sources could be things about other engineering projects or specifications or customer information that's related to that, to really give you that bigger picture of where you're working. So the power of this is really that instead of people making queries and having to think about how to form those searches like you might in Google, where you put in some words and you just keep iterating on those words until you get the results you wanted, you can actually use the content that you have in front of you, be much more proactive and pushing information rather than waiting for it to be pulled by some search action. So some examples of how you can really make use of that in a very simple way. If I go back to that global warming web page I had, we have a plugin into Chrome here. Now, if you wanted to find more information about the things that are talked about on this web page, I could read this web page. Traditionally, I could try and craft some keywords about weather and climate and things and go to Google and do some searching and keep iterating on that and get some information, and then come back to where I'm trying to do my work. I have to context switch away to do that. We have with our plugin, you can simply click on the plugin and immediately get all of the information that is related to the content on this web page. So it's done all the hard work for me. I haven't had to work out what the right terms are. It has gone away, understood the page, and brought me back the links. So you could imagine perhaps if you're that engineer again, looking at information on a website that's about, I don't know, something you're currently working on, some project you're currently doing, maybe it's in Africa or something. You get instant access to all the supporting information from your internal projects in that box there. Maybe there's specifications related to the work you're doing, or information about other tenders for similar pieces of work. But you can also include external information about maybe the economics of Africa or the best practices for working in that country. So you can really pull in the full context of things you need to look at to do your job in workflow. So another example here revolves around the authoring of documents. So if you're in an application like Microsoft Word, now when you're writing a document, often you're actually an expert in the subject that you're writing on. So why actually might you want to search at all, you might ask? Well, kind of who knows what else is going on in your organization, what other people are talking about, what's been going on. Things change fast in the world around you today, and you might not have been involved in all of the conversations that are relevant to this. But because you're an expert, you think you know what's going on, you tend not to search. But if that relevant information is pushed to you in real time within that Word environment, you might be surprised what you uncover and how much easier it is to get the right documentation written first time. So let me just go back to this global warming thing here, and let's cut and paste this text out of here because I don't want to type into Word directly. So what will happen, I'll speed that up, is it's done exactly the same thing. It's taken the text that you're writing in the Word document and provided you insights from all of the different data sources that are available about relevant information that you might want to read that will help you author this document. And so maybe a great example of this that we've talked to people in the past about is if you're perhaps a lawyer and you're reviewing a legal document in Word, the information about other similar contracts can be available to you that you might use to ensure you're using similar clauses or related project documents to ensure that you've got the right compliance standards being used and referred to. So you can even do things like, rather than using the whole document, maybe you choose a section of a document and you could just get results relevant to that section. So that could have been your critical term in your contract you're trying to find information for. So you can cut down that information set. Something else I think that's often overlooked is the ability to keep up to date about what's going on. Now, your company might have an intranet page with what whoever's authored that intranet page thinks that you should look at. But what if it showed you what you needed to know about your organization and externally that's related to you? The interesting thing here is that if you can set a discovery term, you can get that information pushed to you. So here is a tool. It's harder to demonstrate this one real time, but you can put terms in that you'd like to know more about, and then and the sources you'd like to know it from, and it can very easily daily return you blasts of information that are relevant to what you're trying to do. Now, one of the things that I think is really interesting about this is that the search terms can be dynamic too. So if you use something like a URL as a search term, the content of that URL can change too. As the world moves on and extra information is added to that page, or things change about the thing you're looking at, your results will be relevant to whatever it's changed to. So actually, it isn't just being informed about new information that comes along. It's actually might discover existing information that now becomes relevant because the actual thing you're changing, your querying has changed. And these are things that are very useful, because when you tend to do research for something, how often do you do that research? Once? What's the likelihood that 10 minutes after you finish your research, some really significant article appears that actually would be very relevant to what you're doing, and you don't go back and search again because you think you're finished? So being up to date and informed about relevant information really can help you build the right thing, and actually engage with other colleagues in your organization who are building information and make it available to you to do work. So this really can, I think, being aware of all the information around you really can save you time and support your work and remove perhaps significant risk from your work too. So these are things that really bring data and information to you within your work context. And these tools can work within pretty much any tool. So your CRM, for example, could be displaying information from knowledge bases about customer issues or other similar customers, or issues you need to be aware of. For example, this is really going to allow people to be aware of the information around them and to use it to be the best person they can, being kind of empowered to do the task efficiently and use their skills rather than spending a great deal of time searching or being frustrated that they cannot find what they need. So let's just look at a bit of a different example. This is a bit of a use case that you might not think of, and this is not directly related to our core market, but it is a prototype, and I think it's a really good way of showing how reactive and real-time our service can be. Basically, we can use sources of information that can be converted to text that aren't naturally thought of as text. So here's going to be an example of using speech to drive discovery. You can kind of imagine maybe being a customer support agent and the system listening to the conversations that you're having and delivering real-time insights to support that conversation as it finds relevant information that can be used to ensure that the messages that that customer service agent delivers are accurate first time, reducing call time and maybe the ability to increase that first time response rate, which is a very key metric, used metric in this market. So what I'm going to do is going to turn on this microphone and we'll see what happens. So let's go back and start thinking about that earlier challenge of climate change and how that affects the world of flooding and weather effects. Okay, so turn the microphone off again. So here you can see that it transcribed everything I said real time and delivered results across all of the knowledge sources that are available that are relevant to the thing I was talking about, which could help inform that conversation. So really, you can see that the system can return information very quickly based on that information. All of these demonstrations that I've just showed you are available on our website for free. If you want to go try them out yourself, we'd be really happy if you did and gave us any feedback or thoughts you have from them. So go give them a go. So I like to think that the values here that we've just seen are sort of fall into three categories. They're frictionless, flexible, and fast. The three Fs. So what I hope you've seen, it helps you understand how you can provide frictionless access to all of your data with little or no preparation. The raw data can really be consumed, removing the need to invest huge data management programs. We've seen the power of pushing data to people in place rather than expecting them to go and pull that data from many places and have the diligence to do that themselves. We've seen how removing the search term and using the context can expose lost information as you don't search until you found what you want, which I think is that self-fulfilling prophecy and kind of echo chamber effect. Instead, it provides the most relevant information to you first time. It provides great flexibility in terms of consuming data from wherever it is, whatever format it's in, and allowing you to use that unstructured data that before was a closed book and formed that 50% of data that we talked about earlier that isn't found by employees, and in that 80% of data that's going to appear going forwards. I think it's fast in both time to implement because there are no major data cleansing processes or expectations on employees to categorize data that require training plans and process flows to be implemented. But it's also quick in terms of getting results instantly to remove barriers to using the data in those everyday workflows. The business benefits, I think are all about bringing data to the people within workflows that ensures they're using the information resources that are available and delivering the best outcomes without those huge overheads. Getting all the data enables the best choices to be made across the business, not just from within the silo of the organization that they primarily operate in, but really opening it to the wider ecosystem. And using all the information they have to create new content. Don't reinvent the wheel, utilize your IP and move forward faster and encourage collaboration across teams, departments and geographies. So I'm going to try and show you how you can bring all this together in another demonstration. Let's bring that up. Okay, so this is a full application that uses the techniques that we've already talked about, not just to discover information, but to make it actionable and begin to deliver insight. We call this our insight for commercial teams, and we developed this to solve a problem identified in that engineering sector, where there was a huge influx of tenders to be managed from multiple sources, and the time and effort taken to establish the best opportunities was high, and too much resource was being wasted reviewing and approving the right opportunities and actioning them to the best outcomes. To solve this problem, we needed to be able to identify appropriate opportunities using discovery techniques, and then use some insight techniques to categorize, prioritize, and label collaboration. So let's have a bit of a quick look at how this works. So what you're looking at here is something that is pulling opportunities directly from this government opportunities and specialist tender source. And this is a dynamic source that is continuously pushing tenders out. So this system uses that raw data and pulls it in and builds the understanding of all of those opportunities that are available and brings them onto the screen here. And there are lots and lots of them. So now you've got a challenge. Okay, I've got all the opportunities. Which ones should I work on? You know, different people and different teams have different skill sets and different core abilities. So I really want to see the opportunities that I can work on. So I can use a definition of my skill set, my department, my team, or some other textual definition of the piece of work to find relevant opportunities to that definition. So all of these departments in here are just descriptions of those departments and the services and skills that the people in those teams have. And it uses that to find all the relevant opportunities by matching their understanding of those two things. So now we are just looking at a list of opportunities that are relevant for that department. Now, that's a start, but now I've got a list of opportunities. How do I know which is the right one to work on? Sort of traditionally, you'd look at these by which one's going to expire first. So which one have I got to respond to first if I want to win it? That isn't necessarily the most important one to work on, or the most likely one to be successful, or the one that's most aligned with our business need. So with our system, you can instead sort that by the chance of success. Now, that chance of success can be defined in different ways for different customers, but essentially it is using the opportunity itself and its content to look through historical opportunities that the company has previously worked on, whether they were successful, who worked on them, or any other criteria you'd like to define the chance of success. And it uses that information to support that. So if I click on one of these ones that's marked as like to be successful, let's do a refresh. There we go. It's used all of the content of this opportunity to find other relevant opportunities that have been undertaken by the company in the past, and in this case, exposing the team or the person who actually did that work. So we can see that there have been several previous opportunities that have been successful that are related, and we can see who undertook that work. So we can actually go to those people and understand what they did to make that a success. Could they provide help and insight on building responses to this? And then maybe you would hope they would go away and use the word solution that we just talked about earlier to go and author a suitable response using this information to support doing that too. Because this is really all processed in unsupervised mode using that vector search, this can all be real time. Opportunities can appear as soon as they're available. They can be processed through the team through self-selection. Recent relevant work can be seen and colleagues can be contacted who have that experience in similar work. And then you can perhaps use that team stuff to do the word plugin to do a response that we showed earlier. This enables an efficient and lightweight, data-informed and data-supported process that really can bring wins to the team and the companies using it. So what you saw here is that we've used information, in this case, in joined up ways to indicate best outcomes. We haven't relied on any humans processing data, labeling those opportunities to understand which teams and resources are best to use them. And it means you can gain those outcomes instantly. And we have built data-informed and data-driven processes, which are very powerful in supporting the process of progressing the work through the company. So let's come back to this original journey that we looked at. Today, we've walked through the discovery, the power and engagement that it can achieve, and begin to show how it can step towards those actionable insights. But if that's not exciting enough, this is the foundation to a continuing and even more exciting journey to come. The vector search technology opens up the data to enable this journey without having to invest in more and more new technology, getting more value from the information continuously without having to continuously pivot to totally new solutions to evaluate your data. So watch out this space for some more information on these opportunities in future, where we'll be able to dig in deeper to those aspects and how it can support this continued journey of getting even more from that data that you've collected. So with that, I think it's back over to John to run the questions.
Cool, thanks, Ian. That was really informative. So I've got a couple of questions that have come in by email, but perhaps we'll start off with Chris Taylor sent a question into the chat session, which is this. Do you take into account the quality of information, the quality of the data and sources in your search? Unstructured data can sometimes be of low quality or misleading.
So obviously results are only as good as the data it can consume. I think this is one of the big advantages of being able to use unstructured data sources, is you can use the entire content of a document rather than the information that somebody has taken and added as metadata or structure around that to support it. So it removes that kind of human error where people are trying to arrange data in ways. I think it also helps where if you label and arrange data in a certain way, you're putting that labeling on for a specific purpose. If then a new value for that data appears in your business, you might have to go and relabel that data again to make those labels relevant for that new purpose. With us using the raw data in its rawest form and actually using the unstructured data and understanding it, that is a process you just don't have to go through. Having said that, we can use the labels and structured part of data to support our process and help filter and give different results as needed. But the core aspect of using the unstructured data really powers that value.
Cool. So Ian, it's not, if data is mislabeled, if it's mistagged, if it's mistitled, the system that we have is largely agnostic to that because it just uses the actual raw information that's contained in the document.
Yes, actually, and in fact, there are people who would like to use our technology to help assess how good their labeling is by actually using our system to work out which documents are relevant and see how aligned those tags and labels are for those documents to help do some quality control and analysis on some of those systems where they already have documents in ontologies and things to support maintenance and support of that.
Okay, cool. Thanks, Ian. I have another question that's come in a little bit earlier by email, which is, how does this compare to other classic enterprise search tools like Elastic?
Yes, so we try and sort of distinguish what we do from search to being discovery, because I think quite often when you think about search, you're thinking about actually matching keywords and exact matches, which really helps you find stuff, and it can actually be quite good at finding stuff where you actually have an exact matched word. But where you're looking for things that have relevant context, it doesn't really work very well. I mean, we saw with that global warming example, you would have thought all the articles I saw would have contained the word global warming, but actually an awful lot of them would use climate change instead. So how do you know how that works? So using the meaning rather than the keywords is a big difference and really good. But it doesn't just stop there. There are some other things that separate those things. I think you saw the flexibility that our service can offer in terms of joining data sources together and building that virtual data point of truth that you want to query at query time rather than generation time. In things like Elasticsearch, you need to build the corpus of data you're going to search in the way that you want it to be queried. So you may have to have multiple sets of that depending with different data sets depending who wants to query it. Whereas with this sort of vector search technology, you can break the data down for business use rather than for technology use, so that you can actually allocate different sets of knowledge to different people much more easily. Also, things like Elasticsearch are quite hard to scale. You end up segmenting your data and siloing your data for technical reasons, because as the scale grows, you need to pull it apart into different nodes to enable it to operate fast enough. The vector search technology doesn't suffer from those problems, which means you can segment your data for business reasons rather than technology reasons, which makes it much easier to operate and manage. And I guess lastly, because our system, the vector search system, doesn't rely people to type in keywords, it actually uses that context. You can really integrate it into the workflows like we showed, rather than making it a separate activity that people have to go and do. It becomes just part of the tools they're using, rather than this special activity that they forget to do, right?
Thanks, Ian. Another question which came in by email was a very simple one. If my company wanted to use this, how much data preparation is needed?
Yeah, I mean, I could just say none. It isn't necessarily quite true. A very small amount, certainly. The system just uses the raw data that's there. So the content of the web pages, those content of those tenders, and it gests that data and does the understanding. And that really is one of the huge USPs of this technology. There is sometimes a little bit of things you might need to do. If every one of your documents contains the same 3 paragraphs at the bottom that is a legal clause or something, you might want to strip that off so that you just don't find all the documents with the same legal clause. But in essence, really, very, very little.
Thanks, Ian. Third question that's coming by email, a very simple one. Who is this product for?
Well, I think ultimately we have designed it for people who've got really large amounts of data that they want to be able to use. It's proving particularly useful in that engineering sector because they do have very large, complex information distributed across many systems and geographies. The value of using this is bringing all that data together and seeing the big picture to enable them to do their work. But it really can apply to anyone who sits in that place. And I think nearly every digital workplace has data distributed all over the place for many, many reasons. And this can really help people who want to be able to use it all fast without having to invest in trying to pull things together into data warehouses and things. So yeah, that's who it's for.
Okay, cool. Thank you. So if people do want to ask a question, then please enter that question into chat. Just to give people a bit of time to do that if you want to. More information about our solutions can be found on the information resources that you can see on the page there. So you can go to our website. All the demos that Ian went through today are actually publicly accessible on our website, so you can go and try them yourself if you want to try the discovery demonstration, or even try the speech demonstration if you want to shout at the screen and just see how your rants may actually be indexed to things like archive and Wikipedia. Yeah, more than welcome to do that. And of course, our email address is there as well. As I mentioned at the very, very start, a recording of this will be sent to everyone after this call. Feel free to share that with any of your friends and colleagues should they be interested. And also in that will be the link to the more, I guess, technical webinar that we did last week, where we had Professor Richard Mortier actually going through exactly what vector search is and how it's different to other stuff. So, John, I can see you've got a question there. I'm not sure if I can unmute you to ask that question, so just bear with me 2 seconds. It may be that I have to ask you to type. Just bear with me 2 seconds as I try and work out if I can actually do that. John, hopefully you're now unmuted.
Apparently not.
Well, that's better.
Apparently
yeah.
not.
Oh, yes.
How can you do any quality assurance on the output of what you extract, what you get together? How do you assess that?
Yes, very good question. It's really hard to define relevance in result sets. There are lots of sets of data that we can use as benchmarking tests, and we have got some benchmarking test results that we can certainly share with you. If you send us some details, we can send those through to you. Some of the difficulty is in what one person thinks is relevant, someone else may not, because it's down to the purpose and the reason they're searching. So, someone who's looking at a document for research purposes might think that the best results are very different than someone who's looking at it for a competitive evaluation, for example. So some of it is down to what's the right information for the right task. So it's not always as clear cut as it seems, but there is benchmarking data that can demonstrate the relevance. This benchmarking data tends to be formed from a source where a lot of humans have scored lots of documents as to how they think they're relevant. But again, that is still skewed by the way those people were feeling on that day, whether they thought it was relevant or not. So you have to always take some of the benchmarks with a little bit of a pinch of salt. But generally, those benchmarking results are very good for this technology, and really show that it's delivering some good results.
Thank you.
I think we're probably being a little bit putting our light under our bushel there to some extent. I think when we have done the benchmarking results, I think, John, it's safe to say that they're actually they're more than good. They're really excellent. So we can actually demonstrate that the results we give back from against what we call the gold standards, where humans have actually gone through and marked the relevance. They are much better, much more performant, much more relevant than there are with traditional systems, just because we look at the entire context of both the input query and of the source documents and can actually give relevance against that. So again, as Ian said, we're more than happy to share those results with you.
I guess more importantly, we very often run very quick evaluations with customers on their own data, and to me, the best indication the results are good is that the customer thinks the results are good for the evaluation they're doing with their data, and that always is the case. So customer testimony is a really good definition of success here.
Yeah, cool. Okay, thanks for the question, John. Any more questions or comments from anyone? Just give a couple of minutes. As I said, we will be sharing this video, this webinar. So if you do want to go back and share with people, more than welcome to do that. And if you do have any follow-up questions after this, feel free to drop us both a line using the contact details we've got on this page. Okay, I can't see any more questions, so I think at that point we'll close this call. Thank you very much, everybody, for your attendance. I hope it's been useful to you. And as I say, if you've got anything else you want to contact us with us, feel free. We'll be more than happy to share your information, share your benchmarking data, whatever it may be, to tell you a little bit more about us and how this technology can really help in business applications. Okay, thanks everyone. Have a great day, and hopefully speak to you all soon.
Bye-bye.
Cheers. Bye.